Assalamu alaikum. Good morning, everyone. Ramadan Kareem. How are you all? Hope you are all okay and doing well. Today's lesson is about segment relationships in circles. In the previous lesson, we took the angle relationships in circles, and today we will start with segment relationship and relationships in circles. Now, our main objectives here in this lesson is to find the length of segments formed by lines that intersect circles and to use the lengths of segments in circles to solve problems. Let's start. Now, and the first one, the first theorem is the chord-chord product theorem. This theorem is talking about the two chords if they intersect inside the circle. Here, if we have two chords, AB is a chord and CD is a chord. They both intersect here inside the circle. As you can see, the intersection point is inside the circle. Now, in here, if two chords intersect in the interior of a circle, then the products of the lengths of the segments of the chords are equal. It is so easy when we translate it in mathematical way. Look here, it means if we multiply AE times EB, then it will be equal to the product of CE times ED. So the product of the parts of each chord is equal to the other product of the second chord. Now our first example is about applying for the chord product theorem. Now find the value of x and the length of each chord. We have here two chords, F, E and H, G. Now, F, E, and H, G here, if we want to find the X, X is the part of the chord G, H, J, H. How much is it? So we will write the theorem. The theorem says that if we multiply F, J times J, E, it will be equal to the product of H, J times J, G. So we wrote it here as you can see, and we substitute EJ times GF equal to GJ times JH. Now we substitute the numbers here, substitute H 10 times 7 is equal to 14 times X. Find the answer. Simplify by dividing both sides by 14 to get X is equal to 5. X is equal to 5. Now we want to find each chord, the length of each chord. Now the first chord is EF. EF is equal to 10 plus 7. This is the segment addition postulate, if you remember, 10 plus 7, which is 17. And the second chord is GH, which is equal to 14 plus X that we already found there, 14 plus 5, which is 19. Now check it out one about same example. Find the value of X and the length of each chord, again like the previous example. Now again here we have two chords. They intersect. Concentrate here. The chords are intersecting inside the circle because later you will see intersection outside or on the circle. Now these two chords are intersecting inside the circle in the point E. Now we want to find the value of X, which is a part of the chord C, D. We will write the theorem. It says DE times EC equal to AE times EB. DE times EC is equal to AE times EB. Substitute the numbers. 8x is equal to 30. Divide by 8 both sides to get x is equal to 3.75. Okay, now we will substitute to get the length of the chord. AB is equal to 6 plus 5 equal to 11. CD is equal to the x, which we found right now, 3.75 plus 8, which is equal to 11.75. I think the idea is so easy and is clear. Okay, the second idea in this lesson is about something we call it a secant segment. Secant segment. What is the secant segment? Is a segment of a secant with at least one endpoint on the circle. An external secant segment is a secant segment that lies in the exterior of the circle with one endpoint on the circle. Now, what does this mean? It means that here, look at this figure. Examples, look here. Look, P, M, and N, M, and K, M, and J, M are secant segments. Look, this is a part of the secant, P, M. Now, the secant, we said before that the secant is a line. Now, this is a segment, which is a part of the secant. PM is a part of the secant. So, PM and NM, KM, and JM are all secant segments of circle Q. Now, NM and JM are external, outside. They lie outside the circle. NM and JM are both an exterior or external secant segment. It is also a part of the secant, but it is external one, exterior one. It lies outside the circle, on the exterior part of the circle. Now, what do we want from this? The second one, look here. The second one, the theorem is the secant product theorem. Secant product theorem. Let's see it like this better. Now, if two secants intersect in the exterior of a circle, they intersect in the exterior of a circle. Before we said it intersects inside the circle. Exterior of a circle, then the product of the lengths of one secant segment and its external segment equals to the product of the length of the other secant segment and its external segment. Simply, it means that the whole times the outside equal to the whole times the outside. What does it mean again? When we translated two letters, it means that the whole secant segment AE times the exterior part, which is BE, is equal to the whole secant, which is CE, times the exterior part, which is DE. So AE, the whole red secant segment, times BE, the exterior one, equal to the whole secant segment, the blue one, times the exterior part, which is the E. How to apply it? It is also so easy. Look here. Now, applying the secant product theorem, find the value of x and the length of each secant segment. Now, x is a part of a secant. As we said, it is a secant segment. X. Sorry. It is a part of it. Now we want to find x. As we said before, we can use, look, they intersect outside the circle. Here it is outside the circle. So to find the x, we will write the theorem, the application of the theorem. Now we will say that GE all times the exterior part, which is 8, is equal to the whole secant segment, which is DE, times the exterior part. So we started from here. 16 is for 9 plus 7. 9 plus 7, the whole secant segment is 9 plus 7, which is 16, times the exterior part, which is 7, equal to the whole secant segment, which is x plus 8, times the exterior part of the secant. Okay, now here we will find the answer. Simplify, move the 64 to the other side by subtraction, then divide both sides by 8 to get x equal to 6. Now they want us to find the value of x and the length of each secant segment. So what is the length of GE? and DE. DE is known, 9 plus 7 is equal to 16, and GE is equal to 8 plus 6, which is 14. Now check it out 3 here for this example. Find the value of Z and the length of each secant segment. The Z, it is in here also, it is the interior part of the secant segment. Now we will write here, look here. We will say the whole secant segment, which is 30 and 9. It means 39. 30 and 9 is 39 times the exterior part of this, which is 9. So the whole is 39 times the exterior part is 9, equal to the whole secant segment, which is Z plus 13, times the exterior part, which is 13. Now we did the distributive property. Now then we move the 196 to the other side by subtraction to get 182. Divide both sides by 13 to get Z equal to 14. Now we want to find the length of each secant segment by substitution. Now the first one is known, LG is all known, 30 plus 9, which is 39. The other one is Z plus 13, it means 14 plus 13, which is 27 units. Now that's all for today. Thanks for watching and have a nice day.